The making of stainless steel, an inside look. Welcome to Everyday Things Uncovered, where we explore the captivating history of the small things that shape our lives. Stainless steel is a highly versatile and widely utilized material in modern times, serving as a crucial component in various industries such as construction, automotive, medical devices, and household appliances. Its distinctive characteristics, including corrosion resistance, high durability, and a sleek aesthetic, render it indispensable in numerous applications. Ever wondered about the manufacturing process behind this exceptional material? The production of stainless steel involves a multifaceted and fascinating process that encompasses several stages, from raw material selection to the final polishing stages. This video will guide you through each step, illuminating the scientific and engineering principles that underlie the creation of this remarkable alloy. The story of stainless steel begins with the selection of the right raw materials. The primary component of stainless steel is iron, a versatile and widely used metal derived from iron ore, a naturally occurring mineral found in the Earth's crust. Iron ore is mainly composed of iron oxides such as hematite, Fe2O3, and magnetite, Fe3O4, which are rich in iron but also contain various impurities. To isolate pure iron, a refining process is necessary involving a series of complex chemical reactions and physical transformations. This extraction is achieved through a sophisticated procedure using a blast furnace, a large, vertically oriented metallurgical reactor where iron ore is subjected to extremely high temperatures, approximately 1,700 degrees Celsius, in conjunction with coke, a carbon-rich substance derived from coal, and limestone, a calcium carbonate-rich sedimentary rock. The intense heat within the blast furnace melts the iron ore, while the carbon from the coke reacts with the oxygen in the iron ore to produce carbon dioxide, leaving behind molten iron. This reaction is crucial in the extraction process, as it enables the removal of oxygen from the iron ore, resulting in relatively pure iron. The molten iron, commonly referred to as pig iron, serves as the foundational material for stainless steel production, although it is still relatively impure and contains impurities like carbon, silicon, and manganese. To produce stainless steel, the pig iron is further refined and alloyed with elements such as chromium, nickel, and molybdenum to achieve the desired properties. Chromium is particularly important as it forms a thin, transparent oxide layer on the steel's surface, protecting it from corrosion and providing its characteristic rust resistance. Chromium is essential for stainless steel's corrosion resistance, as it reacts with oxygen to form a thin, invisible layer of chromium oxide on the steel's surface. This oxide layer prevents further oxidation and corrosion of the metal beneath. To achieve this, chromium is added to the molten iron in the form of ferrochrome, an alloy of iron and chromium. Typically, stainless steel contains at least 10.5% chromium by weight, although the exact percentage varies depending on the grade being produced. In addition to chromium, other elements like nickel, molybdenum, and manganese may be added to the molten steel to achieve specific properties. Nickel enhances corrosion resistance and gives stainless steel a more lustrous finish, while molybdenum increases resistance to pitting and crevice corrosion, particularly in high chloride environments. Manganese improves the steel's strength and hardness. These alloying elements are carefully measured and added to the molten steel in precise quantities, as even small variations can significantly impact the final product's properties. Once the alloying elements are added and mixed with the molten iron, the next step is to remove impurities introduced during the process. This is achieved through argon-oxygen decarburization, AOD, where a mixture of argon and oxygen is injected into the molten steel. The oxygen reacts with carbon and other impurities to form gases that can be removed, while the argon controls the temperature and prevents excessive chromium oxidation. The result is a pure form of stainless steel, with a carefully controlled composition that ensures the desired properties. After AOD, the molten stainless steel is cast into solid form using continuous casting, where the molten steel is poured into a water-cooled mold. As the steel cools, it solidifies into a long, continuous slab or billet, which can be cut into smaller sections as needed. Continuous casting is preferred for its ability to produce large quantities of stainless steel with consistent quality. The slabs or billets are then allowed to cool further before being sent to the next stage of the manufacturing process. The next step is hot rolling, where the cooled slabs or billets are reheated to around 1,200 degrees Celsius and pass through a series of rollers. These rollers apply pressure to the steel, gradually reducing its thickness and shaping it into the desired form. Hot rolling not only shapes the steel, but also improves its mechanical properties by refining the grain structure. The steel can be rolled into various forms, such as sheets, plates, bars, or wires, depending on the intended application. After hot rolling, the steel is allowed to cool before further processing. At this point, the stainless steel has a rough, oxidized surface that needs to be cleaned and finished. This is achieved through pickling, where the steel is immersed in an acid bath, usually a mixture of hydrochloric and nitric acid. The acid removes the oxide scale and surface impurities, leaving behind a clean, smooth surface. After pickling, the steel undergoes several final processes to achieve the desired properties and appearance. Next, we have cold rolling, where the steel is rolled at room temperature to achieve precise dimensions and improve its surface finish. This process also enhances the steel's mechanical properties, making it stronger and more durable. Following cold rolling, the steel may undergo annealing, a heat treatment process that relieves internal stresses and improves ductility. By heating the steel to a specific temperature and then cooling it slowly, we can reduce hardness and make the steel easier to work with. The steel then undergoes surface finishing, where various techniques such as grinding, polishing, or buffing are used to achieve the desired surface finish and texture. This can range from a matte finish to a mirror-like shine, depending on the intended application. Once the steel has been finished, it's cut to specific lengths or formed into various shapes using techniques like bending, punching, or welding. Finally, our steel undergoes rigorous quality control inspections to ensure it meets the required standards and specifications. This includes testing for strength, corrosion resistance, and other properties to guarantee the steel performs as expected in its intended application. The resulting stainless steel alloy is a complex material with a unique combination of properties, including high strength, corrosion resistance, and aesthetic appeal, making it versatile and widely used in various industries. When you see a shiny piece of stainless steel, remember the intricate journey it took to get there. From raw materials to finished product, your input matters. Share your ideas for our next video in the comments, and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching, and if you want to learn more, click the next video right here.